Let's use the unit circle to solve some problems about trigonometric functions and equations. Problem 1 says to first draw the angle theta equals 5 pi over 3 using a ray through the origin, and then determine cosine of theta, sine of theta, and tangent of theta. We are using the unit circle definition of the trig functions. When it's not specified, you should assume theta is in radians, not degrees. Now, one big hint is this involves pi, but even if it did not involve pi, you'd want to assume it's in radians unless said otherwise. Okay, so let's go ahead and draw the unit circle. So this is the circle of radius 1, centered at the origin. So this is 1 here, -1 over there, and -1 down here. Angle of 5 pi over 3. Some people have difficulty knowing how to draw that kind of angle right away, and they want to go ahead and convert to degrees. That's fine. If that's you, go ahead and convert to degrees. 5 pi over 3 radians, which I'll abbreviate rads, can be converted to degrees if I multiply by the conversion factor of 180 degrees over pi radians. Then the radian units will cancel, the pi units will cancel. The 3 will cancel with the 180, that'll leave us 60 degrees up there, and then 5 times 60 degrees is 300 degrees. You know a full turn around the unit circle is 360 degrees. If you go 3/4 of a turn, that's 270 degrees. Add another 30, you'll be to 300 degrees. So right about like that is the angle theta. That is 300 degrees, or in radians, 5 pi over 3 radians. To finish part A here, you do need to have some things memorized, or at least almost memorized, and use your calculator to help you remember them. But let me go ahead and just tell you what to do based on memorization. The unit circle definition of cosine and sine is based on imagining starting at the point 1, 0, right there, and going around, since it's the unit circle, a distance of 5 pi over 3 radians, or just call it 5 pi over 3. Going completely around the unit circle is again 2 pi, which is about 6.28. And the cosine of the angle is defined to be the first coordinate of this point that you see right there on the unit circle, and the sine of the angle is defined to be the second coordinate. So the coordinates of this are cos theta, comma sine theta. And you can see, based on the fact that that point is in the 4th quadrant of the plane, that the first coordinate, cos theta, has to be positive, and the sine of theta, the second coordinate, has to be negative. That's one big hint. You can also see that the sine of theta, being the second coordinate, is very close to -1. And if you remember a special value that it's going to be very close to -1, you'd realize it's going to have to be -√3 over 2. That will have to be the sine of theta. Cos theta is going to be, it seems, about halfway between 0 and 1, and in fact that is a special value. 1/2 is what the cosine of theta is going to be. So let's go ahead and write those down. Cos theta is positive 1/2, and sine theta is -√3 over 2. Now, if you were unsure and you got your technology, you can go ahead and calculate these things. Make sure your calculator is in radian mode, which mine is in, though we could convert to degrees as well. Cosine of 5 pi over 3 is indeed 0.5, positive 1/2, and the sine of 5 pi over 3 is -0.866 approximately. And if you go ahead and find square root of 3 divided by 2, that is positive 0.866. Okay, so we have confirmed that these are the right answers with technology. Now, the tangent of theta, by definition, is defined to be sine of theta divided by cos theta. So just go ahead and use what you found. This is going to be -√3 over 2 divided by positive 1/2. Dividing by 1/2 is the same as multiplying by 2. The 2's will cancel, and you'll be left with -√3, and we can check that as well. Tangent of 5 pi over 3 is that, and square root of 3 is the same thing without the negative sign. Okay, so we've confirmed the answers to part A. Part B, you are given that t is between pi over 2 and pi. Now, you're not told that t is an angle, but you can think of it as an angle if you want, and that is helpful. You're also told that sine of t is 1/3. the goal is to find cosine of t and tangent of t. One temptation here is to think that you need to use inverse trig functions, and we will go ahead and do that as a way to check the answer. But you can do this problem without inverse trig functions. Again, you're not told that t is an angle, but you could think of it that way if you want. Okay, so again, for part B here, I will think of this as an angle. This was part A. Part B, draw the unit circle again. T, if I think of it as an angle, is between pi over 2 and pi, 90 degrees and 180 degrees. It's in the second quadrant. You're told its sine of t, its value, is 1/3, positive 1/3. So again, remember, sine is the second coordinate. It doesn't matter whether you call the angle theta or t. It doesn't really matter. Sine of t is the second coordinate of the stopping point. 1/3 is 1/3 of the way to 1. The point's got to be right about there. The angle's got to be about, if you think of t as an angle, it's going to be about that big right there. Okay? So the second coordinate of that point is 1/3. Cosine of t is the first coordinate of that point. So you just got to find the first coordinate of that point. You could draw a right triangle in here and use the Pythagorean theorem. You could also, because of that, use the fact that cos squared t plus sine squared t equals 1. Cos squared t plus sine squared t equals 1. So cos t, if you solve for it, by subtracting sine squared t from both sides and then taking the square root, well, you need to allow plus or minus square root. It's plus or minus square root of 1 minus sine squared t. Because we're in the second quadrant where the cosine is negative, the cosine is the first coordinate of the point, we need to choose the negative sign. Choose the negative sign. Choose that since we are in quadrant 2. In the upper left there. First coordinate is negative. So cosine of t is going to be negative square root of 1 minus sine squared t. We're given that sine of t is positive 1/3. So that gets squared. Now just simplify negative square root of 1 minus 1/9. Get a common denominator. 1 is the same as 9 over 9. 9 over 9 minus 1 over 9 is 8/9. So this is negative square root of 8/9. Can that be simplified? Yes, you could write this as negative square root of 8 divided by square root of 9, and square root of 9 is 3. That's fine in my book to leave it like that. You also can think of 8 as 2 times 4, and square root of 4 is 2. You could write it as negative 2 root 2 over 3 is the most common way to write the answer probably in this kind of situation. And then, so that's the cosine. And then the tangent of t, once again, tangent is sine divided by cosine. Tangent of t is sine of t divided by cosine of t. Again, the sine of t we were given was positive 1/3. Cosine of t we've just found to be negative 2 root 2 over 3. Once again, the 3's will cancel here because dividing by that fraction is the same as multiplying by its reciprocal. And you get negative 1 over 2 root 2. To me, that's a fine way to leave the answer. You may have a teacher that says they want you to rationalize the denominator, which is fine as well. It doesn't matter. So you'd multiply both the top and the bottom by square root of 2 if you do that. And you get negative square root of 2 over. Go ahead and multiply that out. Square root of 2 times square root of 2 is going to be 2. 2 times 2 is 4. So it looks like the tangent of t is this quantity, which again, I'm fine with leaving like that as well. My students, you don't have to rationalize the denominator. Rationalizing the denominator just makes it easier to check answers. It's also a useful technique in some harder kinds of problems for solving problems. Okay, so those are the answers. And those are the exact answers, and you can approximate them with your calculator. Let's try it with an inverse trig function as well. You do have to be a little careful here. So you're told sine of t is 1/3, but t is in the second quadrant. So if you take the inverse sine of both sides of this, realize that you're going to get an answer in the first quadrant. Okay, by definition, the inverse sine function gives you answers between negative pi over 2 and positive pi over 2, negative 90 degrees and positive 90 degrees. So you can do it, but it's a little tricky. So let's go ahead and take the inverse sine of 1/3 here. Inverse sine of 1/3 gives you 0.3398 radians. I'm in radian mode here. That's giving an angle that's about like this. It's got the same sign, the same second coordinate there of 1/3. To find the angle t that we are after, go pi radians and then subtract this angle that we just found. So pi minus this angle is the value of t. T is approximately 2.801756, say. Okay, that's the approximate value of t. So now if I take the cosine of that, it should be, up to rounding error perhaps, equal to this. Calculator keeps more decimal places internally, so I think it's going to give us the exact value. Cosine of that answer, negative 0.9428. If I go ahead and evaluate this thing on my calculator right there, negative, oops, got to clear that, negative 2 to the 1.5 power, 2 times root 2 is 2 to the 3/2, or 1.5 power, and then divide by 3, that should be the same number. And it is. Okay, so we confirmed the cosine of t, the tangent of t. Tangent of t, t was about 2.801755744. It's about negative 0.35355. So that should be the value here, negative root 2 over 4. Whoops, negative root 2 over 4 is the same thing. We got the right answer. Problem 2 is about graphing a sinusoidal function. Y equals f of t equals 4 times sine of 5t plus 1 in the parentheses there, then outside the parentheses plus 2. This is a transformed function from a regular sine graph with some vertical stretches and horizontal compressions and vertical and horizontal translations. Part A says find the amplitude, period, vertical shift, also called the midline, which is the average value of the graph. It goes through the middle of the graph, and horizontal shift, okay? We'd call this a sinusoidal function, by the way, even if it were a cosine there instead of a sine. Let's label these numbers that you see with common letters that are used. The number in front of the sine or cosine is often called A. The number in front of the little t here is often called B. It's tempting to call the number that's the plus 1 there C, and it certainly is possible. You certainly can do this, but it is actually common to call it a Greek letter phi. Actually, it's sometimes common to call this thing a Greek letter omega as well, but I'm going to avoid that. And then let's call this number plus 2 outside the parentheses D. So that's A, B, phi, or phi if you prefer, and D. The amplitude turns out to always equal in this situation the absolute value of A. So A itself in general is not the amplitude. It could be a negative number, but we want the amplitude to be positive. A does happen to be a positive number here, positive 4, and we get an amplitude of 4. But even if A were negative 4, the amplitude would still be positive 4. What is the amplitude? It's related to a vertical stretch. It is the vertical distance between the horizontal line, that's the midline or average value through the graph, and the maximum value or the minimum value. Both of them is the amplitude, that vertical distance there. The period is the next thing here, often called t. You don't see a t there, but it's often called t. Turns out to equal excuse me, 2 pi over b, and that's related to the fact that the sine or cosine function, a plain sine of t or cosine of t, has period 2 pi. This is also sometimes called a wavelength. When the independent variable for the function is a little t representing time, then you call this thing a period. If the independent variable had been an x, and if x represents a length, then you'd call it a wavelength. It's a horizontal distance between the two peaks. If the graph goes up and down like that, it's a horizontal distance between the two peaks. Or you could think of it as one cycle of the sine wave. If the sine wave starts out, for example, at the midline and goes up, then down, then back up again with the same value and same slope there. That is 1 cycle. That is the period. So in this case, since the b is 5, that's 2 pi over 5. Might be good to just approximate that. That's a little bit bigger than 1. 2 pi divided by 5. It's about 1.2566, just so we have a little bit of frame of reference here. If little t is in seconds, then the period would be in seconds. If little t is in hours, the period would be in hours. The vertical shift is the d. Vertical shift, you could also call it a translation, a vertical translation. That is the d. It's 2, and since it's a positive quantity, it's upwards. And its units would be whatever the units of y is. If the units of y is a distance, then the units of d would be in the same units of distance. If d were negative, which it could be, it would be a downward shift. If, for example, if it was a -2, d would be -2. And the fact that it's negative would imply it's downwards. You could also say it's 2 downwards if you preferred, and you'd think of it as in terms of the absolute value of d, but you'd then emphasize that it's downwards. Probably best to just say upwards in parentheses here. How about the horizontal shift? That's typically the hardest thing to think about here, the horizontal translation. It's especially tricky here when the coefficient of t is something other than 1. Let's write down the function here again. Y equals f of t equals 4 sine of 5t plus 1 and then plus 2. To figure out the horizontal shift, what you're trying to do is you're trying to think of this, if that were just a 5t in there, it would be just a regular sine wave starting out at the midline, going up, then down, then back up again. You have to ask yourself, what do you need to replace t with in that function to get a 5t plus 1 right there? And the way to figure that out is to factor out whatever that coefficient of t is out of both terms inside the parentheses there. Be careful, don't make a mistake, it's a little tricky. This is going to be a plus 1/5 there. Okay, so the phi is 1, but this 1/5 really ends up being phi over b, and that is the horizontal translation. But careful, another tricky part is when it's a plus thing, plus a positive number, when this thing is positive, it's a horizontal translation to the left. People want to think it's to the right, but it's to the left. This is, you could call it phi over b, 1/5, but because it's positive, it's to the left. If it were negative, that's when it's to the right. If you're subtracting, if it's t minus something, it would be to the right. I'm not going to take the time to confirm that, but you should think about plugging in simpler situations, perhaps special values, and seeing that it works. Like just graph y equals x squared and then graph y equals x plus 2 quantity squared. And you'll see that because it's x plus 2, x got replaced with x plus 2, it's going to be shift to the left. You'll see it by just plugging numbers in. All right, let's graph the function next. Part B is to graph the function. All right, so it's a little tricky here. Probably best to draw the midline first. That's the vertical shift, 2 units upward. Let's say 2 is right there. Draw a dashed line at the midline, like that. That's going to be the average value. The function, once I take into account the horizontal shift to the left, is going to start at the midline, go up, then down, then back up again. All right, let's think about the amplitude next. That's the 4 there. That's the vertical up and down distance between the midline and the maximum and minimum values. So the maximum value is going to be 2 plus 4, which is 6. The amplitude is 4. And the minimum value is going to be 2 minus 4, which is -2. That's a 4 as well in terms of units of distance. The horizontal shift, again, is to the left by 1/5 of a unit, which is 0.2. The period's about 1.2566. A quarter period would be 1/4 of that. Let's just approximate it, 1.25 1.25, okay, just divide this by 4, about 0.314. So our horizontal shift to the left of 0.2 units is smaller than a quarter of a period. So if I start here at the midline and go up, the maximum value is going to be to the right of t equals 0. This is the t-axis, this is the y-axis. So the graph is going to look something about like this before coming down again, and this is going to be negative 1/5 right there, negative 0.2. It's going to go back up and reach a maximum at a slightly positive t value before coming back down to the minimum of negative 2 before coming back to the place it started with the same slope right there, and this is going to be negative 1/5 plus the period, which is 2 pi over 5. 2 pi minus 1 over 5, let's approximate that. 2 pi minus 1 over 5, it's about 1.0566 is where that is. And technically the graph goes on forever. It's a periodic graph. That's the point of these functions, in fact, is that they're periodic, going on forever and ever in both directions with, in this case, period 2 pi over 5, okay? So that's a pretty decent graph. On to part C. This is meant to be part C, actually. C, approximate 4 of the infinitely many values of t where f of t equals 0. There are infinitely many values where f of t equals 0. Here are 4 of them that I'm drawing right there, but that continues in both directions. Okay, so let's go ahead and use inverse trig functions here. I want to set this function equal to 0 and solve for t, and I will go back to thinking about the unit circle to help me find all the infinitely many values. So this is, again, supposed to be part C here. 4 sine 5t plus 1 plus 2 equals 0, and I did set this up to work out nicely with some nice special values. Subtract 2 from both sides, and then divide both sides by 4. Sine of 5t plus 1 will be negative 2/4, which is negative 1/2. All right, let's think about the unit circle, and we'll use the calculator to help as well. Maybe we should go for exact values first here. So going back to the unit circle, draw the unit circle centered at the origin with a radius of 1. And we're after inputs for this sine function, which are 5t plus 1, that when thought of as an angle, give a sine of negative 1/2, meaning a second coordinate of negative 1/2. Here's negative 1/2 on the vertical axis there. So we're after angles, so to speak, that the rays intersect the unit circle about there and about there. And this angle, one angle there is going to be negative pi over 6. Another angle is going to be pi plus pi over 6, which would be, what, 7 pi over 6, for example. That right there is 7 pi over 6. Let's use negative pi over 6 as well. Negative pi over 6 is negative 30 degrees. Positive 7 pi over 6 would be 210 degrees. Those would be examples of angles whose sine is negative 1/2, if you want to just double check one. Sine of 7 pi divided by 6, for example. Yep, negative 1/2. And that's going to represent 5t plus 1. So 5t plus 1, let's do this kind of thing. Let's write some different values. I could write infinitely many things here, but I'm going to just write 4. Then maybe I'll put dot, dot, dots to indicate there's infinitely many values. So one value is, I'll go ahead and include the negative pi over 6 and 7 pi over 6. And how about negative pi over 6 plus 2 pi, bringing you back to this ray here. Negative pi over 6 plus 2 pi. And how about 7 pi over 6 plus 2 pi? 7 pi over 6 plus 2 pi. And we could keep going. Those are different values of, not t, but 5t plus 1, because that's the input for the sine function. To solve for t, just subtract 1 and then divide both sides by 5. infinitely many values. Subtract 1, then divide by 5. Okay, negative pi over 6 minus 1, all divided by 5 would be one of them. 7 pi over 6 minus 1, all divided by 5 would be another. I could simplify these things. I'm not going to take the time to. Negative pi over 6 plus 2 pi minus 1. Negative pi over 6 plus 2 pi minus 1 all over 5. And 7 pi over 6 plus 2 pi minus 1 all over 5. Yes, you could simplify these. Maybe your teacher wants you to. Let's just approximate one of them and see if it seems right. Let's try the 7 pi over 6 minus 1 all over 5. 7 pi over 6 minus 1, and divide by 5. It's about 0.533. Let's graph the function and see if that seems to be a place, perhaps right there where the graph crosses the horizontal axis. Go to my y equals screen. 4 sine of 5x plus 1, then plus 2. Window, let's go from just 0 to 1, just to see that intersection point. Maybe on negative 2 to 6, although I could zoom in. There we go. And then we'll find the 0 there. Left bound, right bound, and guess. 0.533. There we go. Okay, we confirmed the answer. In this problem, we're doing really the opposite of what we did in the previous problem. In the previous problem, we were given a function and we tried to draw the graph. In this problem, we're given a graph and we want to find a formula for the function, a possible formula for the function, maybe not unique. In fact, there are infinitely many ways to write these things. All right, so we've got what appears to be a sinusoidal graph, a periodic graph. That's got a certain vertical translation, a certain horizontal translation, a certain stretch, amplitude, and a certain, what would it be, a horizontal compression based on a certain period. Okay, so it's probably at best to identify the midline first. It looks like the highest value, maximum value is 8, and the minimum value is 2. The average of those two, which would be 5, is going to be the midline, and that's going to be the vertical shift. The amplitude is 3. So we got the amplitude and vertical shift right away. The next quickest thing is probably the period. The horizontal shift's always the hardest part. So the period here is the peak-to-peak distance there. So what we have from horizontally from here to here is half a period. 0.55 minus 0.25 is 0.3. So a full period is 2 times that, 0.6. Now the coordinates of this point right here would be 0.25 plus 0.6 would be up to 0.85, comma 8. The period, t, is 0.6 or 3/5. Okay? So the a we can take to be plus or minus 3. The d in the previous problem, the vertical shift, we can take to be 5. And the b, since t is 2 pi over b as we learned in the previous problem, that implies that's equivalent to b being 2 pi over t. So b is going to be 2 pi over 3/5. That'll be the same as 5/3 times 2 pi. And that will then be 10 pi over 3. That is the b. What about the horizontal shift? Well, it depends on whether you want to use a cosine or a sine, for one thing. We used a sine in the previous problem. Let's use a cosine in this problem. That is a little easier, I think, because we're given this high point. The cosine, ordinary cosine graph starts out at its maximum value at when the input is 0. So if I use the cosine, I want a horizontal shift to the right of 0.25, and I would then need a minus sign in the formula. So this problem is much quicker than the previous problem. We can solve this problem pretty quickly and say y equals 3 cosine of b is 10 pi over 3 with this horizontal shift to the right of 0.25 or 1/4. I want to replace x, I'm using x now instead of t, with x minus 1/4. I could have used a t, and it would have been a t minus 1/4. And then the vertical shift is plus 5. That's an answer. Now let's just simplify a little bit. Let's distribute the 10 pi over 3 through the parentheses there. 3 cosine 10 pi over 3x minus, multiply those, you'll get a little bit of cancellation. The 4 will cancel with the 10, give you 2 and a 5. Looks like 5 pi over 6. The phi from the previous problem would be negative 5 pi over 6. Phi is sometimes called a phase angle. Plus 5. So if I've not made a mistake, just double checking things, this looks good, yes. And either one of these answers is okay, and you can check it by graphing. Number 4 is an applied problem similar to number 2, but we'll do it quicker. For a boat to float in a tidal bay, the water must be at least 3.2 meters deep. The depth of the water, d of t, in meters, where t is measured in hours after midnight, is given by this formula. Part A, what is the period of the tides in hours? Little t is in hours, so the period would be in hours. That's an easy part here. The period, capital T, is 2 pi over b. The b is the 0.5 here. That's 2 pi over 1/2, which is 4 pi. Let's go ahead and approximate it. And fortunately, this is somewhat realistic in that 4 pi is close to 12, which is what periods of tides often are. So about 12.56637 hours. You know, you could convert that to minutes as well if you multiply that by 60. But, oops. Let's do that again. 4 pi, subtract 12, multiply what's left by 60. It's about 12 hours and 34 minutes. Okay, you could convert to seconds too. Anyway, that is the period. Part B is definitely the harder part. If the boat leaves the bay at midday, which is noon, not midnight, this is midnight here, what is the latest time it can return before the water becomes too shallow? Sorry if you couldn't quite see that. If the boat leaves at midday, which is noon, what is the latest time the boat can return before the water becomes too shallow? All right, to help us solve this, we really should quickly draw a graph. So here's t in hours. And there's no dependent variable name here, but you could certainly call it something like y. This is in meters. The midline is at 6. Say 6 is right there. The amplitude is 4.3. 6 minus 4.3 is going to be 1.7. 6 plus 4.3 is going to be 10.3. It's a cosine graph. Starts out at its peak at midnight. It's going to go down. This would then be, careful here, the period is not 24 hours, not exactly 12 hours, a little over 12 hours. So when it comes back up to the peak again, that's about 12.0, round it to 12.6 hours. We are a little bit past noon. We're leaving at noon, which is 12. The tide is fairly high, so it's fine. It's going to come back down, though, like that. And we're wondering, when is it too shallow? What's the latest? The water's got to be at least 3.2 meters deep. 3.2, it'd be maybe right about there. So we're after the time, afternoon, the latest time which we can dock the boat. This is going to be the answer, whatever that number is. Okay? That t value. And you could find it in, hours after midnight. You can convert it to something p.m. if you like, as a latest time. All right, so it's a little tricky here. We need to set this equal to 3.2 and solve for t, but we need to find that answer right there, not any old answer. So let's set d of t equal to 3.2. Like that. Subtract 6 from both sides, then divide both sides by 4.3. Cosine of 0.5t. 3.2 minus 6 is negative 2.8. Divide that by 4.3 and get about negative 0.6511628, say. Make sure I copied that right. And now you can use inverse cosine to solve for 0.5 times t, which is t over 2. The inverse cosine function, if I apply it to this, always gives me an answer between 0 and pi radians, 0 and 180 degrees, but think in terms of radians. It's negative there, so it's actually going to be in the second quadrant between pi over 2 and pi radians. Inverse cosine of this answer is approximately 2.2799. 2.2799. That is a number between pi over 2, which is about 1.57, and pi, which is about 3.14. If you multiply that by 2, that will give you one value of t. That would be about 4.5 or so. Looks visually like that's going to give us this answer right there. So it looks like if we add a period to that, that's the quickest way to get the answer. Let's see, got to be careful. I could add a period of the cosine or sine function right away here before multiplying by 2. Or I could take this answer and add a full period of this function, which is 4 pi. Okay, 2 pi times 2 is 4 pi. Let's do it this way. Put the 2 pi there. Go ahead and approximate this. Plus 2 pi. It's about 8.563. Now multiply by t. The answer that we're after is approximately this times 2. 17.126 hours after midnight. So that's going to be a little after 5 p.m. I could subtract 17 from this and multiply by 60 minutes and an hour. About 5:08 p.m. if you want to round it. 5:08 p.m. But of course, in real life, you'd want to play it safe and not get too close to that. You'd probably want to be back for sure by 5 p.m., maybe even 4:45 p.m. Our last problem is to find all the exact solutions of the equation sine of 2x equals cosine of x in the interval from 0 to 2 pi, and this notation means, with the square bracket, means include 0, and with the parentheses, it means do not include the right endpoint 2 pi there. All right, all the exact solutions. This is scary looking. What do I do with the 2 in there? How do you solve things like this? This is pretty weird if you haven't encountered this before. First thing to solve an equation like this, because of the 2x in there, is you'd want to use something called a double angle formula. Now, if there were no 2 there, if this was sine of x equals cosine of x, I would solve it by dividing both sides by cosine to say tangent of x equals 1 and use inverse tangent and that kind of thing. But it's a 2x there and not a 2x there. Double angle formula for sine says that sine of 2x equals 2 times sine x times cos x. If you've never seen this before, it seems really mysterious. If you want to confirm it, just plug in numbers on both sides, and you see that this is what's called an identity. It's true no matter what x is. You don't have to solve for x in this equation. It's an identity. These are the exact same functions. You could graph both of them On separate lines in your calculator, you'd only see one graph. They're the exact same function. So we can use it. Identities are really useful, in this case for solving equations. In calculus, they're useful, for example, with doing integrals. Lots of trigonometric identities are really useful for doing integrals. So let's do that here. Let's replace sine of 2x with 2 sine x times cos x. 2 sine x cos x equals cos x. Solving this equation is equivalent to solving this equation. Now it's tempting to divide both sides by cosine of x here and cancel them and say this means 2 sine of x equals 1. And this equation, if you assume it's true, does imply that as a possibility. But you're ignoring situations where cosine of x might be 0, and that would make these two sides equal to each other as well. So you don't really want to do that. It would give you some solutions, perhaps, but not necessarily all solutions. But what you can do is you can subtract cosine of x from both sides, and then notice that both terms now on the left have a common factor of cosine of x, which can be then factored out, like this. So if this is true, that implies this is true, that implies this is true. That implies cosine of x equals 0, or this thing equals 0, 2 sine x minus 1 equals 0, which after adding 1 back to both sides and dividing both sides by 2, sine of x equals 1/2. We'll solve both of these equations for solutions in this interval. And it then does turn out you can double check that those possible solutions are actual solutions with the original equation. You can check that by plugging in the original equation. I won't take the time to do that. The solutions of this one, cosine of x equals 0. Think about the unit circle. I'm not going to make a drawing. I'll just use my fingers here. Cosine of x is the first coordinate of the point. When is that 0? It's when the point is at the top or the bottom of the unit circle. Angle is, in radians, pi over 2 radians, or 3 pi over 2 radians, 3/4 of 2 pi. X equals pi over 2, or 3 pi over 2. Sine of x is 1/2. Sine is the second coordinate. Special angles. You know it? Pi over 6, 30 degrees. And 5 pi over 6, 150 degrees. Use radians. We're assuming radians here. Pi over 6 and 5 pi over 6. And these four numbers, the work we've done is confirmation that these are possible solutions. They are solutions. You can check them, plug them in here. You'll see that it works. Maybe it's worth going ahead and graphing both of these functions. This is not an identity. This is an equation to solve. This was an identity. This is true no matter what x is. Let's go ahead and graph both functions. They're not going to be the same function, and we'll see visually where they intersect. Sine 2x and cosine of x. Window 0 to 2 pi. Let's make the tick marks on the x-axis. So how about pi over 6 units apart? In the y direction, the amplitude is 1, so -1 to 1 is fine. All right, here we go. There's sine of 2x. It oscillates. It goes through 2 periods because of the 2. And here is cosine of x. Where do they intersect? Here, 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 and here. These 2 points are pi over 2 and 3 pi over 2. This one right there is pi over 6. You can see it matches up with that tick mark there. And this one here would be 5 pi over 6. It matches up with the 5th tick mark. 1, 2, 3, 4, 5. Matches up, okay? So it looks good. Thanks for watching.